So for the x-intercept, we let y be equal to 0. So we have 0 equals x squared plus 2 over x minus 1. Multiplying both sides by x minus 1, we have x squared plus 2 equals 0. And again, we're not going to get x squared equal negative 2, so we have no x-intercept. The y-intercept, we let x be equal to 0, so we have 0 squared plus 2, or 2 in the numerator. 0 minus 1 is negative 1. So we're getting a y-intercept of negative 2. Step 2, finding the vertical asymptote, we take the denominator and set it equal to 0. So we have a vertical asymptote of x equals 1. Step 3, we want to find the horizontal asymptote. The degree of the numerator is 2. The degree of the denominator is 1. So the degree in the numerator is greater than the degree in the denominator. That means we have no horizontal asymptote. We're just following these rules here. And we do long division. We have x minus 1 for a divisor, x squared plus 0x plus 2 is the dividend. X goes into x squared x times x is x squared, x times negative 1 is negative x. Change the signs of the second polynomial. X goes into x one time. 1 times x is x, 1 times negative 1 is negative 1. Change the signs of the second polynomial, and we get 3. So I got x plus 1 plus a remainder of 3 over x minus 1. Now, when the remainder, I'm writing it as r of x for the remainder, being 3 over x minus 1, and the degree of the numerator is less than the degree of the denominator, we have a slant asymptote. So the degree of the numerator is less than the degree of the denominator. And we get an equation for the slant asymptote from the first part of our quotient, and we get y is equal to 1. So again, I have a slant asymptote at x, y equals x plus 1. A y-intercept of 1, a slope of 1. Then I take the denominator, set it equal to 0, it gives me a test point. I tested to the right and left of that, and then it told me what area, whether I'm shading above or below in those regions. I got positive, so that's why I shaded up, and then negative, then I shaded below, between those, the slant asymptote and the vertical asymptote. Okay, again, so we have an x-intercept, we have 2 of them, positive, negative 2. Y-intercept, we have negative 4. Then a vertical asymptote where x is equal to negative 1, and no horizontal asymptote. So now we need the long division. X plus 1 is the divisor, x squared plus 0x minus 4 is the dividend. X goes into x squared x times, x squared plus x, change the signs of the second polynomial. X and x is negative 1. Change the signs of the second polynomial, and we're getting negative 3. So I have a remainder of negative 3 over our divisor of x plus 1. the degree in the numerator is less than the degree in the denominator, so I know I have a slant asymptote, and the equation is going to be where y equals -1. Y equals x minus 1. I don't know if I said that correctly. Okay, so let's see what we have. We have an x-intercept of +2. We have an x-intercept of -2. We have a y-intercept of -4. We have a vertical asymptote of x equals -1. We have no horizontal asymptote. We have a slant asymptote of y equals -1. Y equals x minus 1. So we have a -1 for the y-intercept and a slope of 1. Our remainder was -3 over x plus 1. The numerator is not going to give us a test point, but the denominator is. It's going to give us a test point of -1. So we're going to check on either side of that. We're going to check x is equal to 0, and we're getting -3 over 1, which is a negative in this region. And we're going to test on the other side, let's say -2, -3 over -2 minus 1 is going to make that a positive. So what we're getting is that it's going to approach the vertical asymptote here and the slant asymptote here. And then on this side, we know that it has to come up in this region here, and it has to go down here this way.